we are picking up where we left off on Friday in lesson 3.7. And on the front of lesson 3.7, we talked about even and odd functions, right? We talked about if it's an even function, it's symmetric across the y-axis. And we talked about if it was an odd function, it was symmetric about the origin. And another easier way to say that is you could rotate it 180 degrees. Okay, so those were, even and odd. We also talked about algebraically. You had that in your notes. Then on the back side, we started talking about transformations. At the top of the back side, we took those two functions and we broke them down. We looked into, okay, what's their parent function? How are they moving? Are they reflecting? Are they stretching? Anything like that. Today, we're going to take a graph and we're going to write the equation for that. Now, reminder, we have two parent functions here, one of which is y equals x cubed. I pointed these out on Friday, right? Y equals x cubed is this curve. Notice it's centered at 0, 0, and a typical x cubed also goes through 1, 1, and negative 1, negative 1. We also talked about the quartic function. Y equals x to the fourth. Kind of looks like a parabola. It has a vertex at 0, 0, just like x squared. And just like x squared, its first set of points are over 1, up 1. And you want to pay attention to that because these are the ways that we can know is there a stretch or a compression. Okay? Now, our job is to write an equation here. So as we go to write an equation, look at A. What can you tell me about this? What do you see? Okay, we have to know that this is an x cubed graph. And I'm just going to kind of make a couple of quick notes here about, okay, what all do we have to include in our equation? There has to be it has to be x cubed as the parent function because it's got the same curviness, right? Okay, what else do you see happening?
0, 0, it goes right to and then 4.
Okay. If we look at, normally the center's at 0, 0, but now my centering, it went right 2 and up 4. So I'm going to have to include that information in my equation. One other piece of information I need you to point out. How else is this graph slightly different from the graph up in the picture of the parent function?
The lines, like it doesn't go up to the right, it goes up to the left and then down.
Okay, so our curve is going the other way, isn't it? On a normal cubic function, it starts down and increases and ends up, right? If you recall, we talked about this being like down-up behavior. But this one starts up and ends down. What causes that change? A negative out front, which is a reflection. What this is before it moved right 2 up 4, it's taking this graph and reflecting it upside down. And so the other thing you have to include in your equation is the fact that there's a reflection. And it's just going to be a reflection across the x-axis because you could just think it as upside down. Although you could probably think of it as a reflection across the y too, but x is easier to work with. Okay, that's all the information I know. Let's write an equation. I don't remember if the homework uses f of x equals or y equals, either or. Okay. We said there was a reflection, right? Reflection is expressed by a negative, and that negative is going to be out front. So we're going to have negative of what then? What else do we need to include here? Okay, right 2 is x minus 2 because left to right is in parentheses opposite the sign. So I'm going to have an x minus 2. What else? What? Okay, our parent function is x to the third. Because we have left to right, it doesn't go directly on the x, it's going to go over here on the parentheses. So it's x minus 2 to the third. And then up 4 is plus 4. Okay? We're just taking all those pieces and putting them together. Trying to pull all those pieces from the graph and putting them into the equation. Questions there? I did forget to mention, oh well, I'll mention it on the next one. Okay, B. What pieces do you see? What was it?
Left 1 down 3.
Okay, so from the starting point of 0, 0, my vertex went left 1, down 3.
The parent function is valuables x.
Yeah, we need to know what exponent we're going to include when we do this, right? And based on the fact this is our U shape, this is x to the fourth. Technically, it could be x squared too, but we're only working with x cubes and x to the fourth today. That's all I've included in my notes, and I think that's all that's in homework. I guess you guys will complain and let me know if I'm wrong there, but that was kind of what I saw. Any reflection here? No, this is a right side up U. And one thing you need to be looking for and double checking, this is what I forgot to point out in the first one, we need to always check and make sure, is there any stretch or compression? And the way I can tell that is by looking at, okay, here's my vertex, right? Where are those other points in relation to the vertex? In other words, from the vertex, my first set of points should be over 1, up 1. Is that what I have happening here? Over 1, up 1, and over 1, up 1? I do. So that just means this is a traditional quartic graph, no stretch, no compression. But you should get in the habit of checking that because they could throw a stretch or compression at you, couldn't they? So just kind of beware there. Okay, write this equation. F of x equals?
X plus 1.
Okay, left one is going to be x plus 1 in parentheses. What else? Okay, to the fourth. And if there's no left or right, then that fourth does just go on the x. But as long as there's a left or right, it goes outside the parentheses. Down 3, minus 3. Anything else? No. Okay, C. What are the pieces we know?
X to the 4th.
Okay. U shape? Okay. X to the 4th U shape. Although, should I really call it a U? Katie? Yeah, it's upside down, isn't it? So since it's not really still a U, that means that there is a reflection across the x-axis.
It's straight.
Let's talk about how far we moved first. We'll come back to that one. Where's that vertex at?
1.
We moved right 1 and up how many? Is that 5? Because this is 1, 2, 3, 4, 5. As opposed to what they do in the horizontal. They count by halves, didn't they? Okay. They're being tricky, aren't they?
Mm-hmm.
Okay, which is why I said I wanted to come back. I wanted to get this part out of the way first, and then come back and talk about stretch or compression. Because yeah, this is half, 1, 1.5, 2, 2.5, 3. So, last thing we need to check is there a stretch or compression? Katie might have changed her tune now. Okay, so what would, in a quartic like here, your first set of points are over 1. In this case, it'll be down 1. So if I go over 1 is going over 2 spots. Down 1 is just going down 1 spot. Do those match up?
Yes.
It does, doesn't it? They changed the scale and tried to trick you. They tried to make it look like a compression, in my opinion. But you have to pay careful attention. And just because they counted by halves here doesn't mean they counted by halves here, or vice versa. Okay? So, no stretch or compression. Just make sure you're checking. Okay. F of x equals, what do we got?
Negative.
There's a negative out front because it's a reflection. Right one is x minus 1 to the 4th because there's a parent function, quartic. Up 5 plus 5. Okay. D. Moving right along unless you guys have questions. What you got for me on D? Okay, back to the cubic, right? Back to the curvy thing. Besides it being a cubic, what else do we know? How about left 3, down 1? That centering point goes left 3, down 1, right? If you look carefully for that centering point. What else? Okay. Is this going the wrong way again? Instead of starting down and ending up, instead of having down up in behavior, it's up down. So this is again a reflection across the x-axis. Any stretch or compression? No, because both of the neighboring points are over 1 and then up or down 1. But I checked. That's the important part. Okay. F of x equals what?
X plus 3.
Negative for the reflection. Left 3 is opposite the sign, so x plus 3 raised to the power of 3 because it's a cubic. Down 1 is minus 1. Okay. One more. Okay, this is a quartic. And what else? They're nice and told you the vertex, didn't they?
Right 2 and 6.
Okay. Right 2 of 6. They labeled that nicely for us, didn't they? No reflection, right? It's right side up U. Stretch or compression? It's hard to tell, but they labeled those points, didn't they? How do you get from 2, 6 to 1, 7? Over 1 and up 1, isn't it? Okay, over 1, up 1. So on the bottom, they count by 1s, 1, 2, 3, 4, 5, 6, 7. But on the side, they count by 2s, 2, 4, 6, 8, 10, 12. So you have to watch out there. But if I check those specific points, it's over 1 up 1, so we're good. Okay, final equation. F of x equals, okay, x minus 2 to the 4th plus 6. Okay, your homework to be working on is lesson 3.7 in Savas. Okay? Everyone should be working on it, unless you already have it done with a 100%. Okay? Otherwise, you should be working on it. Let me know if you have questions. It is very doable to get it done within this period. At least that's what third hour demonstrated. So.